Welcome, everybody. I'm so glad that you're here. I am with Warren Powell, who is a distinguished Emeritus Professor from Princeton University in operations research. He now owns or is part of a startup company, Optimal Dynamics, and he's had an illustrious career, done everything that everybody would hope that you should do in the academic game. And I reached out to him because he was very interesting in how he's communicating on LinkedIn. So I wanted to see what his thoughts are. And today what we're going to do is begin with his career and how he sort of evolved into being a researcher and now working within startups. So thank you so much.
Well, David, I appreciate you having me on. It's a couple of years ago, as I was retiring, I won a prestigious Lifetime Achievement Award in my community, and they invited, it's given every 2 years and everybody always gives a talk. And I decided to make my talk sort of a story of my life. Now, I started my field in transportation science. The Lifetime Achievement Award was from the Transportation Science Division. But my career has started in transportation, moved to very many other problems, has ended in transportation, because that's what my startup is doing. But it's evolved in many different application areas, which is what's really driving all of my writing today. And if I were to meet somebody young today, I absolutely would have some advice of, here's what I would do today, knowing what I know now. Let me end on that.
Okay.
Because I remember when I started my career, I had written a dissertation that was very mathematical, wrote some nice papers, got me a job at Princeton, was otherwise just useless, just completely useless. And I found that out when I tried to get funding. I couldn't get funding from anything. It was in trucking, but it was a queuing theory type thesis, just utterly useless, okay? And when I went out to get funding, and I had developed a contact with one company that worked in trucking that had funded my dissertation, and they very quickly, it's like, well, here's the problem we have. And suddenly I was working on a completely different problem, but grounded in a real application. Now, that problem I ended up spending a lot of time with. It wasn't really my dream. I ended up encountering a different problem, also in trucking, but a different part of trucking, truckload trucking. Think of truckload trucking as Uber for freight. I have a load of freight to move from A to B. It's a full truckload. Okay, this takes the whole truck, just like Uber, only moves one person at a time. And you have to find a driver. You have to decide what driver to put the load on, what load to put a driver on. The loads usually take a day or two, even 4 or 5 days to go cross country. And I have to think about what the driver is going to do in the future, which is uncertain. And that drew me into this general area. I have a decision, optimizing the driver, and uncertainty, which driver should I use given what will happen in the future. Intermingling decisions and uncertainty ended up being the story of my life, okay? And I took that into all kinds of different applications, but I just fell in love with it, okay? I just like, wow, what a great problem. When I was first introduced to it, and it was from somebody at a major trucking company, and that already had optimization models. This was an early pioneer of advanced analytics. And this guy had a master's in operations research, and he understood that. So they had pioneered a particular model that looked into the future and pretended that they know the future perfectly. And he says, we don't know the future perfectly. Could we give shippers a discount for calling in their loads in advance? In other words, what was the value of information? And I just remember sitting there over dinner going, wow, what a great question. I not only don't know the answer to the question, I don't know how to think about it. And that became my passion. Now, unfortunately, truckload trucking, these companies were way too small. They didn't have money for funding me at research. So what I ended up doing was always doing it under the table. I was constantly working on that problem while getting funding from some other source. But I just love this intermingling of decisions and uncertainty. Now, the big lesson here, so I come from an analytics field, is that I was always grounded in an application. So that's lesson number one, because I have way too many of my mathematical friends who just aren't grounded in an application. They're just doing math for the sake of math. And I can tell you one thing, there's no funding for theory. The government will not fund theory. I was talking to two program officers from National Science Foundation, one for operations research and one from computer science. And they pretty much basically said, yeah, we don't have any money for theory. And so that was my first lesson, always be grounded in an application. Now, the next thing that I did do, and maybe this was just how my brain was wired, was as much as I was grounded in application, I still took my academics way of thinking to say, let's think of this mathematically. How do I write it down on a sheet of paper? Because at the end of the day, I got to put it on the computer. So I'm not a theoretician by training. I like math, but I'm not a mathematician. And if you want to put it on the computer, you've got to know how to write down the equations. And that forces you into mode about thinking them in a slightly more abstract way. But it was still a model. Every time I did a model, it was for trucking, it was for rail, it was for energy, it was for health. But I did 20 years of work in freight transportation. And then I just started to say, these are great problems, but I just cannot retire having only worked on trucking or even freight transportation. So I made a conscious effort to say, okay, I want to work on something else. And so I picked two areas, energy and health. I would have loved to have worked on health. If you want to work in health systems, do not work at Princeton University. Princeton doesn't have any teaching hospitals. We don't have a medical school. We don't have a big city. You just can't do health. But energy was a great area, and it really worked out. So I set up a whole big energy lab just as energy was becoming hot, and I got a big pile of money. And then from there, I just started to respond to other things as long as they had decisions and uncertainty. Okay. And I just found that that's an amazingly rich mixture. And astonishingly, I started to learn that the academic community was fragmented into all these little pocket communities. So if you want to do what's called deterministic optimization, I want to optimize something, find the best, but there's no uncertainty. That's a really mature field. It's established. There's one way of thinking about problems. There's good tools. They all speak the same language. But if you want to intermingle decisions and uncertainty, that's a mess. I have this slide I call my jungle of stochastic optimization. I have 15 different books, each representing a different community. Okay, so there will be one book called Optimal Control. There's a whole community of people in engineering doing optimal control. And so there's 15 of these, 8 fundamentally different notational systems, all different techniques and whatnot. It is a mess. And so I started tackling that mess and started to have a lot of fun with that. Now, in the process of my evolution, I'd like to think of the career of my father-in-law. My father-in-law was a 50-year academic at Princeton. He was a rocket scientist. So he started in the 50s.
So he was right around just shortly after the Second World War then.
Oh, yeah. He started at Princeton in 1950.
Wow.
He worked on the Manhattan Project.
Wow.
So this was a guy who was a rocket scientist, and every rocket scientist had a great career up until 1969. When we landed on the moon. And as soon as we landed on the moon, all the funding went away. You know, there were physicists driving taxis, you know.
Oh my gosh.
So he just shifted and started up an energy center. And so he ran Princeton's first energy center for 10 years in the 1970s. And in the early 1980s, he says, okay, I'm ready to move on. Somebody else took over the center. And he decided that his passion was that he was going to conquer the problem with diesel fuel. Apparently, diesel fuel produces certain pollutants that are really problematic. And he kind of finished his career on that, declaring failure and saying, okay, diesel can't be fixed. But he had to make these pivotal shifts. And I was very aware watching him make these shifts, because that's another one of these lessons. Whatever path you go down, because if you're young, you can't just sort of pick from a supermarket of options. When you're starting out, you only have so many contacts. You have a certain skill set, which is narrow, because when we're young, we don't know as much.
Yeah, yeah, that is so wonderful. And I was thinking as you were going about doing that is and I hope you're okay with me interrupting every once in a while.
Yeah.
Um, so you had your father-in-law to connect with, and you probably grew up in the New Jersey area. What about
In
those people
Princeton.
that are
We're both Princeton professors.
so you were right in Princeton then?
Yes.
Wow. So
Right.
what about the people that are in Brazil or someplace where they're looking at watching this? Because that's part of why I actually do this is so that there's people all around the world that
Okay.
watch these videos. How
So
on
this.
earth do
So
you?
let me tell you. So late in my career, but I was still teaching, and I love teaching, both the grads and the undergrads. My department was called Operations Research and Financial Engineering. The undergrads in it, sorry, these are Princeton undergrads, and my department is somewhat mathematical. These kids are bright. I mean, I just love these students, but I started realizing that I had a very big message. Okay, decisions and uncertainty. Okay. And over my career, I didn't just do trucking or energy or health. I did all kinds of problems, one of which is because Princeton undergrads have to write a senior thesis. And I ended up supervising 200 senior theses, and the senior theses are not constrained by funding. So I worked on all kinds of countless projects. And it's amazing how many problems you can come up with that have decisions and uncertainty. I mean, that is an infinite problem class. So, like, if I'm sitting here today telling somebody young what to do, oh, my advice is flat out decisions and uncertainty. Now, go pick your own context. It doesn't matter. As long as it has decisions and uncertainty, you're going to have a good time.
Tell me how exploration exploration actually applies in this circumstance.
Well, so that context of exploration and exploitation arises in a very specific subclass of sequential decision problems that I call optimal learning problems. So these are problems where the only problem is to learn. So if I'm trying to find my way the shortest path on a graph, I go from one node to the next node to the next node, and every node that I'm at determines what decisions I am. Learning problems don't work that way. I try an experiment, and every iteration, I have a set of experiments. I have different drugs I can try. I can try different prices for my product. I can try different people for a job. Every iteration, I make a decision, and I learn something from it. The tech people, the Facebooks and Googles, they have to try putting up URLs for products, and they want to put up the URL that gets the most ad clicks because that's how they make the most money. These companies use this field known as multi-arm bandit problems of, hey, I got this thousands of products I can advertise, and each one I have a very rough estimate of how many clicks I'm going to get, but it's very rough. And sometimes I have to try something that doesn't seem to be that good, but that may just be because I don't have a lot of data and I had some bad luck. It's very noisy. So there's this exploration exploitation trade-off. There's a number of ways to do that trade-off. If you go to my big fancy book, Reinforcement Learning Stochastic Optimization, go to chapter 7, and you can download chapter 7 for free. So my big book, the URL is tinyurl.com/RL and SO. Now, it'll look like you can download a couple of chapters, but you can actually download any chapter you want by going to tinyurl.com/RLSO chapter X. And then just replace X with the number 1 through 20. Chapter 7 is a 7 dedicated to these learning problems. Now, the chapter is titled Derivative-Free Stochastic Search, but it's exploration versus exploitation. And for any sequential decision problem, you can approach with any one of 4 classes of policies. And if you Google 4 classes of policies, I've got all kinds of places where you can learn about that. Most importantly is my URL, tinyurl.com/SDA links. So SDA is Sequential Decision Analytics. SDA links is a web page of links. It's a resources web page. Go to SDA links, tinyurl.com/SDA links. And there's all kinds, there's videos and books and downloadable books and web pages and whatnot. But any sequential decision problem can be solved with any one of 4 classes of policies. Now, of the 4 classes, sometimes all 4 apply, sometimes only one is obvious. learning problems, there are two classes that I call CFAs and a type of look ahead called the knowledge gradient, which is a look ahead class. Both are very, very useful in different settings. The CFA class you can code on a spreadsheet. It's really easy, and it's what Google and Facebook use. Okay, so Chapter 7 discusses all four classes.
And how would this? So if you were thinking like a graduate student, you're using some sort of strategy like that, or some sort of exploitation trade-off problem, which from what I understand, and it's that the exploitation is more of the now, it's more of trying to have concrete returns, and then the exploration is going to a space that you don't quite know, and it's very random.
Okay, well, let me be clear. You're talking about learning problems. This is not a general sequential decision problem. This is a learning problem. That's a very special subclass, okay? So imagine I have a set of choices. I'd like to choose the best choice. Now, I don't know how good the choices are, but I have an estimate. And around each of the choices, not only do I have a point estimate, I have an interval, because I'm not sure.
Mm-hmm.
And I get to try the choice and learn something so I can tighten my uncertainty.
Mm-hmm.
Now, there's no physical state. So imagine, let's talk just briefly about problems that have a physical state. I'm running around a graph. I'm managing inventories. I'm managing people. I'm building facilities. Anything physical. Anything physical. Anytime you have anything physical where you act on the resource, or it could be money. I could be allocating vaccines. The world of sequential decision problems, the massive part of the world, you're managing physical resources. People, equipment, facilities, product, agricultural good, medicines, anything physical, anything that can't be in two places at the same time. Knowledge can be in two places at the same time. I can know something, I can share it with you, now we both know it. Okay, so learning problems are a very special class. They happen to be a very important special class. Okay, so think of sequential decision problems think of optimal learning problems as my state. Instead of being how much inventory I have or where I am on a graph, it's what I know. It's my knowledge, my state of knowledge. And by trying something, I can learn, and now I have a better state of knowledge, and I can make better decisions. Nothing physical. There's no money, there's no vaccines, there's no people. Once you put something physical in it, when you act on them with a decision, you change the physical state. So I like to talk about three classes of state variables. The physical state variables, I call it R sub T. Then I have what I call other information, which is basically anything that I know perfectly that's not a physical state. The third class is belief states. This is anything I don't know perfectly. Now, a pure learning problem, this is where the exploration, exploitation stuff rises. Those are pure learning problems. Those are things where the only state variable is my belief. Now you have pure physical state problems, an inventory problem, the shortest path problem around a graph, any type of scheduling problem, the silly location problem. There's an endless, countless array of physical problems. Okay, you can have problems where you have an information state, let's say the attributes of a patient that walks in with a disease. Now, what disease does he have, or how will he respond to different medications? I don't know. I have a belief about that. And so I may say, okay, I have a rough idea how this medication works, but I may have a rough idea how it works on the whole population, but I've got to have an idea how well it works on this one specific patient. So if this drug works equally well or badly on a whole population, then every time I try it on any patient, I learn about the whole population. But if it's patient dependent, I have to look at age and weight, and is he a smoker, and gender, and all of these other messy things that characterize a human being. Then when I see how well the drug works, I don't learn about it for the whole population. I just learn about it for somebody with all those same attributes. And that's called a contextual bandit problem, much harder problem. But anyway, they're all just sequential decision problems.
I mean, it's super fascinating, and you clearly have this enormous breadth of knowledge. And I think about the one person, and I usually try to capture, one person that's maybe in the north of Brazil, and they're thinking of getting into graduate school. So thinking about what you're saying is maybe find people that are comparable that you can compare with on the internet, and try to learn something from them in terms of going to different
Let me
programs.
tell you one thing. So first of all, let's divide the world into people who are roughly analytics types versus people who are physical science people, the chemists, the physicists, the engineers, okay? Now, all of them have sequential decision problems. Now, the physical science people aren't going to be as interested in the analytics, but I used to work with material scientists. Long story, I landed a very large grant with the Material Science Division of the Air Force Office of Scientific Research and spent 5 years rubbing shoulders with real world physical scientists. And I hired a postdoc who was an applied math physical science type, and he was fabulous. He's now a professor at University of Buffalo. And I reached out to him about a year ago, and he says, "Oh my God, Warren, it's amazing. All these physical scientists are talking about Bayesian optimization." So that's their word for it. And because all experimentalists have to do sequential decisions. Now, the physical scientists aren't too much interested in the analytics, and they don't want to do anything fancy. If you're not a physical scientist, but you still need to do something that's a little intellectually interesting, well, then you want to learn the math. And the math comes in, it can be really not very complicated, all the way up to incredibly sophisticated, because once you intermingle decisions and uncertainty, it can get as complicated as you would like.
Mm-hmm.
But it doesn't have to be as complicated. But let me tell you something. My framework is, my first real book that pulled it together appeared in 2022. It's very, very young. Now, I first finally pulled all this together in 2014, and I wrote 3 papers, but it finally pulled together in my big book, Reinforcement Learning and Stochastic Optimization. But what I strongly recommend, I wrote a book for my undergraduate course, Sequential Decision Analytics and Modeling. It's available as a free download. By the way, all these books are available at that one link, tinyurl.com/SDA links. And the book is called Sequential Decision Analytics and Modeling. It's had 17,000 downloads from all over the world. People love it. It's a teach by example book. So it'll give you the universal framework in chapter 1. And then I've got a dozen other chapters of example, all written the same way. So it's a 300-page book. You don't have to read all 300 pages because you can just pick whatever examples interest you. But every application chapter, which is every chapter other than chapters 1 and 7, it's by example. Then what you do is you're not going to work on any of the problems in my book. You take the style and adapt it to any problem that you would like. And I will tell you, the math is correct, but it's practical. It's very practical. Now, go find a sequential decision problem, which, by the way, they're everywhere. You know, anytime you have a decision, it's a sequential decision problem.
So you have this uncanny ability that I think is remarkable, listening to you, that you can look at all of these problems, even from going from your father-in-law, who is a rocket scientist, to energy, to transportation. You have this remarkable ability to see analogs, to see matches with what you're looking at, which is, I think, is a very difficult skill.
Let me tell you how it starts. By the way, I wasn't born with this.
How did you do that?
No, I wasn't. This comes from, first of all, being an academic, but always working on real problems. But the big thing is I worked on a very wide diversity of problems, okay? Between what happened in my lab and all the undergraduate senior theses, you need a diversity of problems, because I have endless colleagues. They only work on vehicle routing problems or network design problems or supply chain management problems. They always work on one class of problems. And if you work on one class of problems, you get very good at thinking the way that class needs. So what developed my way of thinking was the diversity of applications. And so what started to come together very late in my career, and I was sitting in a classroom with my wonderful Princeton students and saying, okay, I've got these 30 really enthusiastic students. And by the way, as much as they're wonderful students, they're still undergrads. They have one and only one interest. I'm sorry, even at Princeton, or maybe I'll say especially at Princeton, they have one and only one goal: get the degree.
Get a job.
No, from Princeton, get the degree, because the degree gets them a job, and they really, honestly, don't care what they learned.
Yeah.
And by the way, the people hiring them don't care what they've learned, because the people hiring them know that what they're getting is bright kids. Okay, so what we do is we do a lot of hoop jumping, so in my department, a lot of the kids would go to Wall Street. I remember one student asking me, he came back from Wall Street a year after he graduated, and says, "Gee, Professor Powell, we don't use any of that fancy stuff we learned at Princeton." And the simple fact is, the real world has all kinds of complicated, messy stuff going on. And the faculty are clueless. The faculty know nothing. The faculty know math. That's it. The faculty know math. Okay. And so we teach them a whole pile of math, and then we send off the students, and the students have to do hard problem sets and difficult exams, and somebody gets an A and somebody gets a B. And so you graduate, and the simple fact is, it's all just hoop jumping. Sorry. And I realized that my message needed it had a much bigger audience than that classroom. And so this is where I started working very hard to build up my LinkedIn profile. I'm up to 48,000. Within about 3 or 4 months, I'll break 50,000. I'm really excited about breaking 50,000. But it's not just 50,000 random people. All of my posts, if you watch them, they're pretty nerdy. They're all decisions and analytics and whatnot. This isn't TikTok here. This is people who are interested in nerdy analytics stuff.
Absolutely.
By the way, I just posted if you see LinkedIn, I just a few hours ago posted, this is the web page I am most excited about, tinyurl.com/what is a decision.
I love that.
tinyurl.com/what is a decision. I use ChatGPT to go all the way back to the great philosophers of Aristotle and Descartes and whatnot. Nobody knows what a decision is.
That's absolutely right.
Princeton University, I had a professor, Daniel Kahneman, he's passed away, but he's a megastar, 500,000 citations. He's off the chart. His whole field was the psychology of decisions. Never wants to find a decision. All the great minds on decisions focus on mainly two topics. First of all, they're always thinking about discrete decisions under uncertainty, something complicated, and always with uncertainty. So the number one thing they're talking about is, how do they deal with the uncertainty? And then, given the uncertainties, and how do you characterize uncertainty? How do you go about choosing? Let me tell you what they never, ever talk about. How do you even define a decision? How do you even identify the decisions? So I actually have a whole section on my new webpage on this, where I describe a situation. I went out to visit Amazon. Amazon had a workshop for academics, and then they took us on a tour of a fulfillment center. And I was early into my what is a decision phase at that point. And I walked around there constantly saying, what's the decision? And this is something only a human can do, is to say, what are my choices? What are my options? So the young professional who's age 25 starting out, hey, guess what? Pull out a sheet of paper. What could you do? What are your actions? What are your possible paths? And just sit and think about that. The number of times as an academic that I would finish a paper, send it to your journal, sit down at my desk and go, oh my gosh, what am I going to do next? And you know what I would do? Instead of thinking about all the topics I might work on, I would just reach up and grab whatever was on my mind at the time. And then put 1,000 hours of work into it. I'm like, this is just crazy. I'm just grabbing whatever random topic pops into my brain. I should be making a list and then ranking them and saying, okay, this one looks like to be the most interesting. That simple exercise of simply listing your choices. So I have.
So I think that's actually the point with Daniel Kahneman. What he points out is people don't do that. Right? Like
I'm the one making the point that people don't do that. He assumes that people have already done that.
Right. Okay.
Now, often it's the case that you have so let's say I choose here's a bunch of research topics I could do. Okay. what do I want? There's all these uncertainties. Will it get published? How interesting will it be? Will I get funding? Will it lead to other research? All of that's uncertain at the time that I pick the topic, because I don't really know that until I've worked with it for a while.
Mm-hmm.
What you really should do is to sit and say, hey, what are the different topics I could work on? Now think through the different attributes. What Daniel Kahneman does is he assumes the list is already there. And then he starts working on okay, how do we deal with the uncertainties? And then how do we choose? So for example, dealing with uncertainty, dealing with risk, that's what really engages the great minds, the great philosophers.
So you follow more of like Jim March then, and how you're thinking about things. I don't know if you've read any of his stuff or anything, but he was a student.
I'm sorry, what was the name again?
Jim March,
No,
James March, James G. March, and he's
heard that name.
So it's March, like marching or March in the springtime, and he's passed a few years ago. We passed out, but it's all about the basic understanding that managers make these learning decisions that are incredibly difficult to actually make, and yet they still make them. And it's trying to figure out why we do the things that we actually do, and why do we learn in the certain ways that we do. So he was the first one to introduce, part of the reason why I love the idea exploration, exploitation. He was the one that first introduced that into this was back in 1991. And he's had quite a bit of influence in terms of engaging with our audience. But the idea is that the challenges of being a real human being or a manager is often extraordinarily difficult to do, because we have all of these duties. And he's got this great book from 1974 with Johan Olsen about ambiguities of experience, but or with the uncertainties that we experience. And it's fascinating to realize that most of us deeply grapple with these things. We don't know what to do often. So I love the fact that you're tackling what is a decision. Like, how do we even begin?
Yeah. So I'm pulling one step back from that, because what he's doing is, I'm pretty sure he's still assuming that we already know what I had this talk where I've used one graphic. It's Dorothy from The Wizard of Oz, and she's walking down the yellow brick road, and she's at a point where she can go in 4 or 5 different directions. I think what James March is doing, along with all the other great philosophers and Daniel Kahneman, is he assumes that we already know the options. I just don't know which one to take because of all the uncertainties. So exploration, exploitation always assumes you know what the options are. So I recently stumbled into the fact that when we want to solve a problem, what do we mean by a problem? So I have two classes of problems. I call it metric focused and decision focused. So decision focused problems are ones where there's well-defined decisions. I know what the decision is, what to invest in, what price, what drug. And then there's metric focused decisions where, so my daughter works in public health. She wants to have fewer people dying from opioid overdoses. Or maybe I want to run a supply chain, but I want to make it more robust. Or I had this cement factory, I just want to lower the cost. That was an actual problem. There's a wide range of problems where I know the metric. I know what I want to achieve. I just don't know how to go about doing it, which means I may not even know what the decisions are. So that is totally human. Get a whiteboard and a 6-pack of beer and blue sky it, and you have to sit and say, here's things we can do. So the word idea has multiple meanings, but one of its meanings is something to do. Hey, I can go down this path or this path or this path. Identifying those paths often is a light bulb moment of, oh, here's something we could do. Now, whether you want to do it, that's a whole different question. Now, I've also become, as I've been very aware of this, so I watch my son and his management team with the startup company, where they have hard problems like they want to increase sales. Or we have a very sophisticated project to optimize trucking companies. We want higher utilization. So we had the metric. The question is, what actions could I take to optimize that metric? In other words, what are the decisions? Now, when I say, well, what are the things that you're considering? I get a blank stare and they're like, okay, don't go away, Dad. I don't know what you're talking about. Because what they've done is, and we humans often solve problems this way. In fact, very often. We have some goal or metric or something we want to get at. And I'm sure you're familiar with the decision tree, right?
Mm-hmm.
Okay. So a decision tree assumes
So,
that
so what is, so for the audience, in case people don't know what it is, what exactly is it?
Okay. So it starts off, you're sitting at a node and you have a list of things you can do. And each thing you can do takes you to another node, at which point something random happens. And you have to coin flip when the random happens, it takes you to another node where you have more decisions. And at every decision node, which they usually draw as squares, you have to explicitly enumerate what are the choices you have. And decision trees insist that you have to explicitly enumerate those.
Mm-hmm.
Whereas my experience watching humans make solve actual problems is very often they don't enumerate.
Absolutely
They just somehow pick.
Yeah.
And so what's fundamentally assumed in the decision tree is that you enumerate these decisions isn't how many people actually make decisions. In our brain, we somehow, that sounds good. Even if we have to plan into the future, I'm not enumerating everything, I'm just choosing.
So here's this is getting into some of my research and stuff that I'm interested in, is that we tend to not like any of the alternatives that are negative in our minds, or if we pursue something, and this is, entrepreneurship is a great example, or innovation is a great example. It's often has a lot of extra baggage associated with it. You imagine, like you are you're a young assistant professor and you choose, that's, my story of building the Reciprocity Project is you choose to build a startup on there, an application on the side. It's like, oh, what are you doing? You're ruining your career. And it's not only the fact that we don't select all these different alternatives of what we can actually do, but we have a pretty strong bias in the ones that we choose that tend to be positive, outcomes that tend to be positive, but also or expected outcomes that tend to be positive, but also that the alternatives, we're deeply always considering and thinking about what other people are thinking about those alternatives.
Yes, the evaluation of complex alternatives is it's very hard. It's very hard to program.
Mm-hmm.
There's a domain here where it's like, yeah, I don't think AI is ever going to be able to solve this.
Mm-hmm.
So when there was all this to do about AI, being super intelligent, whatnot, I put together this webpage called the 7 Levels of AI, and level 4 is ChatGPT. Level 5 is deterministic optimization. Level 6 is what I do with sequential decisions. Level 7, I call that science fiction. And this is where you have things like reasoning and judgment and creativity. There are these things where, I'm sorry, I don't think any computer will ever be able to crack that. That is just the world of science fiction. Computers have, because at the end of the day, we're all here to make humans happy. Mm-hmm. And so you have to have that human in the loop saying, here's an objective or here's something to do. Because let me put it this way. I like money because it opens up a lot of things else I can do. A robot will never think that way.
Mm-hmm.
A robot can, well, I got my dog here. Robots can only do what dogs do. They do what they're trained. Actually, my dog is more sophisticated than the robot because my dog knows what makes him happy. And a robot doesn't know happiness. It doesn't know, okay, this is a great and wonderful thing. No, I think that is only the domain of humans. So
I think, the people that study that, they would probably, push back a little bit and say that our conception of happiness is just, chemicals and neurons that are firing and, what makes a mind, essentially, right?
Yeah, dopamine receptors. I totally get it. So we've got our dopamine receptors. I'm sorry, robots don't have those. My dog does. My dog does. He knows play. As soon as I get off this talk, he's going to run and grab his squeaky ball and say, "Hey, Dad, let's go out and play." I mean, he knows play. He knows fun. He knows food. But those are, this is making his brain happy is something robots can't do.
Absolutely. So one of the things that I thought was very interesting, I watched your talk or most of it that you had pointed out of sort of your career. And there was these moments where you had to choose to do something that was different, right? Like you didn't expect.
Yes.
Either the environment changed. How did you navigate those tensions? And why on earth are you doing startup stuff at this moment? Like, shouldn't you, as a very
so first of all, I'm not doing any startup stuff. That's my son.
Okay.
My son is amazing. He's an incredible businessman. He's got a huge amount of energy. He's surrounded by people with huge amount of energy. There's absolutely no way I could be doing a startup at this stage of my life.
Okay.
I totally live for my writing, my LinkedIn posts, having this international classroom that I never had at Princeton. Because as much as I loved my undergrads, they were only there for the degree. They weren't there to actually learn. Whereas all the people who reach out and link with me, I like to think that they're doing it because hey, I sort of like these posts. This is interesting. And I do occasionally get some really positive feedback. I had these tiny URL links. A tiny URL will give me a geographic distribution. I can see how many from each country. And in the United States, I can see it state by state, or in Canada, province by province. So I can see a rough geographic distribution. And it's really cool to see people all over the world downloading your book.
It's amazing.
Yeah. I'm telling you, this last one, I really think that my What is a Decision webpage, if this isn't life-changing for you, then you're just on autopilot and you're not thinking. Because what it challenges you to do is to think about what you could be doing.
Mm-hmm.
Just that awareness, that little red book of looking at a problem and saying, here's things you could do. That's something that we're not taught. I have a LinkedIn, I have an email list with 600 Princeton faculty, and I have another 500 or 600 person email list of just faculty of IEOR departments. And occasionally I'll blast them when I just want to get a very specific target audience. And I took some time to put these lists together. And one thing I said, guys, we need to be teaching about decisions. And just in the same way, virtually all schools have statistics courses. They have statistics courses for different communities. They have for the very non-analytical communities, like sociology, whatnot, they'll have one style of statistics, and then they'll have a slightly more advanced version, and then an even more advanced version. They usually have 3 styles of statistics depending on analytic sophistication of the audience. I absolutely think we can do decisions the same way, starting at the very basic level. So
what is it?
I've got a new book. I'm writing a series of books, in volume 1, which is with the publisher. It's called Framing the Problem. 130 pages, no math.
You should. So Andrew Van de Ven, he passed away a few years ago at University of Minnesota. Had thought a lot about this in terms of figuring out what a problem actually is.
Well, I start with 3 questions. What are your metrics? Because if you don't have metrics, then I don't know that I can help you very much. If you're into the who should I marry type of stuff, or what direction for my career, some of this stuff is just messy. What are your metrics? Start with your metrics. Number 2, very hard. What are the decisions in English? So I have and the number 3 is what are the uncertainties? So I have a book series that I'm calling Bridging from Problems to Decisions. I think it's tiny URL. If you go to the SDA links, it'll have the link there. Just look for the word bridging. And it'll be a series of monographs. There'll be 100 to 150 pages. And the first one will appear probably in January. But if you email me, I'll send you the link to it. I'll just send you the book. And it basically, chapter 1 is an overview. Chapter 2 has a long list of applications where for each application, such as inventory problems or various health problems or supply chainy problems or things like that, I give a whole list of metrics, a whole list of decisions, a whole list of uncertainties, without regard to math, without regard to anything, just listed in English, okay? Now, volume 2 is where I take the step to says, okay, now I'm going to use my universal modeling framework. Now, there is some math, but very basic math, just modeling math, and I have 5 elements to any sequential decision problems. What do you know? That's the state variable. What are the decisions? What are the uncertainties? And then what's the transition function that takes you, that says, how does the state variable evolve over time? And the 5th one is, what is your objective function? This will not tell you how to make a decision. It will tell you how to evaluate a policy. And it repeatedly, over and over again, it says, and we will deal with that in volume 3. So as soon as I get volume 2 done, it's 99% done. I'm going to work on volume 3, which will be the policies. Now, I have other books that already fill that in. But
so this is truly fascinating. I really see the connection with a lot of management stuff that we deal with and think about, from problems to coming up with, what is the actual solution. I'm thinking, so part of the problem of why I actually started going online and reaching out to people, I'm trying to build this application of creating nearly non-rejectable research papers and grants. Whether you believe, the idea is to do a lot of the things that you're talking about and make it explicit in the sense of trying to make this fun, what we actually do. That's how I got involved with the internet in the first place. What would you suggest that I do if I've got this hard problem of, how do you inspire people to pursue different things, interesting problems? I often find that is the hardest thing. It's not necessarily like studying, but it's the hardest.
Everybody should pick a problem that they can be passionate about. Okay, so I can come in with anything that you want to make better. So at the very top of my new webpage, although I've used this thing many times, I have, if you want to build a better, and then in brackets, I have supply chain, health system, energy system, ... anything, you have to make better decisions. That's my headline. Okay, so whatever you want to do better, if you want to do something better, you want to make better decisions. So first of all, start off by picking a context that you're going to be passionate about. Okay, because whatever you do, you got to be passionate. You got to be excited by it, and that has to come from within you. But I'm sorry, every human process we're trying to do better. I mean, name a single human process where you're not trying to do something better. Okay, so once you've picked your application domain and subdomain and subdomain, something that you can be passionate about, something where in a cocktail conversation, when somebody says, hey, what are you working on? You want to be able to have a 3-minute, wow, this, and have everybody saying, oh, that's a great problem. Okay, so you've got to pick that problem for you, but then apply my 3 questions. Give me the metric. Tell me how you're going to evaluate to show that you're doing something better. And by the way, usually it's more than one metric, so I suggest building a pyramid, because I don't want just a list. I want an ordered list. But then number 2, the hard part is that list of decisions. What are the knobs? What are the levers? What are the things that you can go in? But the mistake that's made in the academic literature in my community is we come in with a technique for making decisions. Don't do that. List the decision first. Don't worry about how to make it. Because at the end of the day, you're going to use one of the 4 classes of policy. So don't worry about how to make the decision. Okay. Just start off by listing the decision. So volume 1 of my book has these long lists of decisions to illustrate. Don't worry. Now, it's not that you're going to make every decision. You're not going to focus on every decision, but start off with a list. And then from that list, you can stand back and go, okay, I think the decisions with the highest impact will be this and this. Fine. But start off with your list. Now, acknowledge the uncertainties, because there's always uncertainties. And that's your starting point. No math, no technique, just a list. Now, you want volume 2, although I can point you to other things that I've already published, such as that STAM book, which has the teach by example style, because now they're fairly simple examples. My new book is going to go into a much greater depth with some notation, because without any notation, it's just hand waving.
Mhm.
Okay, I'm sorry. I don't want heavy math, but when you try to do it with no math, then it just gets vague and empty. And so I'm going to show you how to model, but I'm going to show you how to model any sequential decision problem. This isn't going to be watered down. This is going to be the full-blown, here's all the notation you need at a high level. Okay, because I'm not telling you specific problems how to model it. I'm going to give you a general modeling vocabulary, what's called a canonical framework. I will not, in volume 2, tell you how to make the decision. That's volume 3. And when you consider all 4 classes of policies, my community always wants the most complicated method because that's what's publishable. I'm really much more interested in people in a problem domain where I have about 7 ways to evaluate a policy, only one of which is how well does it work, because that's not the only way to do it. Transparency, flexibility, simplicity, there's other dimensions, because I think you should look at all the different policies and say, you really always want to start with the one that's simplest, that makes sense. Okay.
So, Professor Powell, given that we're just about out of time, listening to your conversation, it's clear you're still extraordinarily enthusiastic about your research field, and I think you're going to continue doing this for many years to come. How does a young graduate student, so I have a whole bunch of followers that are researchers, PhD folks, all around the world, how do they maintain your level of enthusiasm for your
You've
field?
got to pick stuff you like. And so I will have to admit, my unique screw loose is I love modeling. I just love modeling. Okay. Now, I started off in trucking because, you know what? I didn't like public sector transportation, and I just didn't know about any other problem other than transportation. That was what was in front of me. And I moved over to trucking because when I was graduating, it was just being deregulated, and it became an interesting problem. Trust me, nobody wakes up when they're 6 years old and wants to work in the trucking industry. Okay? That has to be an acquired taste. But what always fascinated me was this sequencing of decisions and uncertainty. But you can have people, like health is a really neat problem. Everybody loves health. I did supervised a lot of health senior theses because every student who couldn't think of a problem to work on always had some family member had some health issue, okay? But energy, and energy isn't one problem. Energy is a whole wave of problems, and there's countless energy problems. Of course, I had a few finance problems, but generally those students went to the finance faculty. But occasionally I ended up with a student who wanted to do finance, and we did a finance problem. But any application area, and I just think that I tend to find that people are most motivated by the application area. Now, if you're mathy, and I was mathy, and you like sort of analytics, you're probably going to want to start with a problem where you can do the really clean analytics. Don't start off with a problem that's too messy, okay? Now, I have a slide where I have 2 ladders. And one ladder is how realistic is your problem, the model, how realistic is the model. And the other ladder is the policy for making decisions. And I claim you should climb these ladders, starting from the simplest. Start with a simple model, and then start with a policy that's suitable to the model, not too complicated, and then start climbing, okay? And as that, you will mature in the mathematical modeling. Now, one of the neat things, if you have any analytical interests, this is not a mature community. Most academics don't know how to do this. They live in the world of the jungle of stochastic optimization. So there's endless people who's, sequential decision, that's dynamic programming. You've got to do Bellman's equation, which is completely wrong. Okay, I'm sorry, it's just wrong. Okay, there's a sub-community in OR that love to do this thing called stochastic programming that's just utterly useless. Okay, you want to pick the class of policy that is suitable to the problem. The reason why volume 2 doesn't even tell you about policies is because I have this phrase called model first, then solve. So the model says, let's model the sequence and the physics. So think of a simulator. If I want to have a simulator, and every time I need a decision, just assume I've got some black box. So I go to the black box, okay, here's the decision. Don't worry initially about how to make a decision. That is completely reverse of what the academic community does. Completely reverse. It is the right way to do it. Model first, then solve. But
I love this.
But
I
it all
love it.
starts with thinking about your problem, and think about a good problem. Think about a problem you're excited about. There was one professor in a business school working on some stupid production problem. And then she starts talking to me about this problem of invasive weeds and an invasive species. And it was clear that's where her passion was. And I'm like, that's a great problem. Study invasive species. 10 years later, there she is doing a poster presentation on invasive species. And I'm like, yes, this is great. Because she kept thinking that she had to work on some problem that was just like everything else in the academic literature.
Exactly.
And she said, no, don't do that. Work on something that's fun. Invasive species. So invasive species, the metric is easy. You want to cut down on the invasive. What are the decisions? Guess what? Not so obvious. You got to sit and think a little bit. You got to do some work. You got to talk to some people. What are the knobs? What are the actions you can take? And that has to be done in English on a sheet of paper. There's no other way to do it. But once you have that list, now you're off and running in my framework.
That's a great spot to end in terms of making sure that you venture off and go do wild and crazy things, because why not, right?
Well, this is the reason why I had always anticipated working till I was 75, and then the stars lined up that says, no, Warren, it's time to go and launch a separate career. And this is now what I do. And I walk my dog. I come back. Every time I walk my dog, I come back with an idea. It turns into a LinkedIn post. And when I'm not doing LinkedIn posts, I'm doing book writing. But one thing that I'm doing, my first big book is by Wiley. They will not allow me to post the PDF, but I did post every single chapter. But all the other books, by the way, tinyurl.com/RLSO chapter X, that is not on any website. So that's one where you have to actually write that one down, because I don't have that on any website. Wiley won't allow it. But every other book, I've got this publisher called Now Publishing, where what they do is they say, look, for 4 months, they want to try to publish the print version, and then I can post a PDF on my website for free. And so the SDN book, 17,000 downloads. I've got another book with about 5,000 downloads. I've got a new monograph series that I'm going to do, and I'm hoping for good things from this.
And everybody can find you on LinkedIn if they want to. And actually, Professor Powell is extraordinarily active on it, and will reach out to you almost immediately.
I do my best. I do get quite a bit of responses. So sometimes the best I can do to respond. But when I get a thoughtful comment, generally I'm responding.
And we deeply appreciate everything that you do. We deeply appreciate the fact that you had this enthusiasm for education, the number of students that you must have affected, and graduate students. Just thank you. It's very nice to
Thanks for helping to spread the word.
So I think I'm going to cut it off right there. And I don't know if there's any sort of requirements you have. I don't do a lot of editing, because I'm like you. I'm trying to build this as I go. And so it's challenging to do this. So I try to be as just open and honest to everybody as much as I possibly can.
Well, I have really found that this metrics, decisions, and uncertainties, think about what you're trying to accomplish and think of that as a metric, okay? And maybe multiple metrics, but it's good to think of what are you trying to accomplish? But then the decisions are, what can you do? So you've got this podcast, that's one thing, okay? But you always have to be aware of, what can I do? What actions can I take? Now that is stuff you think about when you're walking or brushing your teeth or driving the car. I mean, nobody knows how to program that. I don't, maybe ChatGPT could help, but I don't know. I am finding ChatGPT is useful. I was just doing some research on how does Aristotle think of decisions, and
yeah. It's very good with that kind of stuff.
Yeah, it really helps with that kind of research. I loved it when I said, how did Daniel Kahneman define a decision? And ChatGPT came right back and says, Daniel Kahneman never defined a decision. It's very clear. And because defining a decision, actually creating that list, I I haven't seen anybody do some serious thing about it. I don't have any guidance beyond you just have to, that's the thing that pops into your brain.
Yeah, I think what Jim March would have pointed out, so he is, for all intents and purposes, he is the sort of founder of the field of management. And he would have focused more on choices. What do we do? What are the actions we choose? Why do we choose those actions? Not necessarily the decision as
well, actions, coming up with a set of actions is a different word for, so I have my new webpage has 5 classes of decisions. The third class I've really struggled with. One of them, I give it 3 names, one of which is actions.
Mm-hmm.
I just think decision tree. I was trying to say, what word do I use? The decision tree people do not define a decision. They try to define a decision. And, and it's just goofy. It makes no sense. It doesn't even apply.
Very difficult. Yeah.
It doesn't even apply to their own examples. Okay. So I'm like, okay, well, they have this definition that Ron Howard came up with of an irrevocable allocation of resources. And then they have an example for pricing where, I'm sorry, pricing is not an irrevocable allocation of resources. It's a parameter that you're setting. Okay. So I've come up with a very generic definition of decision, which is just very generic. It's anything you control. But it's so generic, it's almost not useful. So I said, okay, so what are 5 classes of actual types of decisions? And so the 4th class is functions, choosing a function. That's a very important type of decision that people completely overlook, but it is clearly a decision.
But what do you mean by a function? Is that?
Okay. I have all different examples. A performance metric is a function. How to make a decision, a policy is a function. How do I forecast the future? There's different ways to do forecasting. Those are functions.
Gotcha.
So the function is the discrete logic, not its parameters, because usually functions have parameters. So my 5th class is the parameters, because parameter search is a very familiar problem class.
There is this paper by so Dan Leventhal. You probably would be able to resonate with some of the stuff that he does. Dan Leventhal is at UPenn, and he's done some work in terms of simulation work that sort of builds on conceptually similar ideas of what you're doing. And they got this paper with Torben Knudsen in Germany at this moment, and they were looking at both. How do you come up with the uncertainty of coming up with alternatives? But then once you come up with the alternatives, how do you deal with the uncertainty of the alternatives themselves?
So there's 2 steps you have to do. One is to model that uncertainty in some way. Now, I like to model it in the real world. You don't model, you just live it. But the second step is then how do you make that decision? Because often in the policy, you have to peek into the future, but not always. Okay, but the real challenge there you're asking is not so much how to model it, although that's a real problem, but it's also, but now how do I actually make the decision? And then I say that's volume 3.
And that's what I would argue that's interesting, is that for the most part in management literature, they have a presumed kind of way of these decisions are actually made, or that often the huge bulk of it now just doesn't really assume that managers really or are interested in the decision themselves. They sort of assume that there's behavior that happens, and the behavior is a reflection of all of these decisions that have happened.
Let me say, by now, I think I can say with considerable confidence, because I've been repeating this hundreds of times, however you make the decision, I claim that if you describe how you're making the decision at a level that you can code into a computer, I will put it into one of my 4 classes of policies. Okay, I claim that my 4 classes of policies covers every method that's ever been published, any method that's used in practice, and any method that hasn't even been invented yet. These are meta classes. Okay, and when you look at the 4 classes, after a while you go, okay, I see what he's doing. The meta classes don't tell you actually, each meta class covers a whole, think of them as 4 rows that each split into many different ways. They don't, you don't have your problem solved when you pick a meta class, but by realizing all 4 meta classes, there's entire communities that work in each of these 4 meta classes. The direct look-ahead class, that's the 4th class, that splits into a whole pile of, when you look ahead, you can look ahead deterministically, you can look ahead stochastically. If you look ahead stochastically, then that breaks into, there's entire books written on particular ways to do a stochastic look ahead. Entire books. I wrote one of them, okay? A whole book on one way to do a stochastic look ahead. It ends up not being very useful. So I have a wonderful book that even I now say, yeah, and it's not very useful.
And so that's pretty funny.
It's great for publishing. It got published, and it is at use in my son's company. So we have one great application. However, 15 years ago, I would have been saying, oh, approximate dynamic programming. Look, I could optimize big trucking fleets. It must be able to do everything. Older and wiser now, I can say, yes, it is very useful for optimizing trucking fleets. Do you have a trucking fleet? Oh, well, then it's really good for that. There are thousands of papers that illustrate the use of approximate dynamic programming. Most of the papers call it reinforcement learning. Most of these papers don't work outside of the journal. They're just journal fodder. I wrote 100 of them, but there's thousands others, thousands and thousands written, and they don't work anywhere outside of the paper. They're just journal fodder. When you actually get out into real problems where everybody, I gave a talk at Cornell University last April. I have a department up there. The 2 of my students teach there. And I had this picture of a crowded urban street intersection with all types of young people running around, and say, look at this urban, there must be 1,000 people in the picture. And imagine it's a young urban crowd, probably mostly college educated. So here I am talking to an art department where everybody knows what a linear program is. And I say, how many of these people in this street have even heard the phrase linear program? And they all nod and says, yeah, almost none of them.
Nobody cares, right?
Okay,
no,
so we want to teach everybody linear program. Now, how many of the people in that city street make decisions? Everyone. It's a human thing. Everybody makes it. So how is it that everybody makes decisions, and yet the OR community lives for linear programming and nobody solves linear programs?
Yeah,
I have a slide that has a set of discrete choices, and it has a bar indicating how good each choice is, and it has error bars because I don't know how good each choice is. I've got this uncertainty, okay? I think that's the 99% problem. I think that's the problem, that 99% of decision problems are, here's a set of discrete choices. I don't know which one's best. I don't even know how good they are, okay? So you started off right off with this exploration versus exploitation problem. Now, I could make that problem more complicated, but inherent in that is the exploration exploitation. That is the universal decision problem that every human deals with. So, and guess what? We don't teach it. We view it as a very specialized topic. It's the multi-armed bandit problem, and there's all this complicated math because we're dealing with optimal policies and proofs, and we make it very mathematical. Okay? And yet this is the universal problem that everybody faces. And I'm like, why aren't we teaching it?
Yeah.
Well, for example, the ability to simply articulate the choices. Sometimes they're obvious, sometimes they're not. You know, I can name problems where like, yeah, I know what the choices are. And I can name problems where like, I have no idea what the choices are.
I think you would find the Ambiguities and Experience book from Olson in March from 1974 very interesting.
Okay. I'll go take a look.
Yeah, it's in fact, this is when I got tenure here. I that was the book I chose to add to our library and put a little signature in it. And it talks a lot about these kind of things, the sort of challenges that we face of, you know, why is it so difficult to do these things? And there's the sort of optimal, you know, there's the OR version of how world works, and then there's the rest of us that are sort of challenging.
Yeah, but the OR world, the OR world is people who look through the world through these very specialized lenses, where we only see linear programs or Markov decision processes or any one of our pet techniques. And so I'll have people going, they honestly think linear programs are everywhere because they only look for things that they can, oh, there's a linear program. Oh, there's a linear program. I mean, imagine if all we were looking for is squirrels. And oh, there's a squirrel. Oh, there's a squirrel. Squirrels are everywhere. I'm like, yeah, but actually there's very few in the universe of things I'm looking at. There's very few squirrels. But if all you do, this is what we do. We teach these techniques, and then we look at the world through the lenses of the techniques. So my volume 1, where I said no math, only English, is my way of saying we've got to get out there and just describe problems in English. And start in English, and that's where I start with my metrics, decisions, and uncertainties, acknowledging that there's problems out there where I actually don't know what a metric is, and I'm willing to say, you know what, I don't know that there are some problems out there where I just don't know that I can help you with.
Yeah, you're not qualified.
Yeah, it's like, at the end of the day, if you want to think about decisions, you want to think about an interesting decision problem, and not every decision problem is interesting.
Yeah, and I have a different take. This is when I actually started going online, and I don't know how much time you have, so I don't want to. When I started doing this, I thought it would be very easy to sort of optimize your way and A/B test your way. And after hundreds and hundreds of times of doing that, I realized it's impossible. And I also realized that literally nobody cares. And the problem is, how do you get people to care? How do you get them to resonate? So it's like, talking to everybody is seeing the world in OR problems, as an OR problem, and they don't see that there's a different way to do it, right? And how do you go? How do you have that conversation?
I've had friends in OR who really, senior people who really get insulted because they seem to think that when I say that linear programming problems aren't everywhere, they seem to think that linear programming isn't useful. And I'm like, that's not the same thing.
It's not the same thing. No.
It's useful, but there's just not very many of them. And it's not a problem that we're teaching linear programming. It is a problem that we're not teaching how to solve this basic problem of a set of uncertain choices. So, I mean, you literally, the first thing you settled on was the exploration versus exploitation. I think that's because that's the far more common problem.
Mm-hmm.
That is the decision problem that we do all encounter.
Mm-hmm.
And I've got some great slides on that. I have a little video that I did from one of my talks on exactly that problem. And I compared 2 types of policies. Of the 4 classes of policies, there are 2 that are really useful in different settings. One is hey, what's the best ad click where I get thousands of clicks? I get a lot of trial and error. And then there's the world that's, I think, much more common where I can do trial and error, but the trials are expensive. It takes a long time to try something.
Or they don't exist. You can't do it.
Well, that makes it really hard. But even the ones where, it takes a week to run an experiment, or it takes me a month to see how well something does. I mean, there's a lot of problems where trying something takes a long time and it's noisy. Those are the really hard problems. And one of my students came up with a technique called the knowledge gradient. It's a value of information policy. And we really found that it was a useful way to approach what I call these expensive problems. Things that are very hard to evaluate. It's a little bit more sophisticated because it's a look-ahead policy. Anyway, David, I've really enjoyed this. It's really neat. I love your passion for this. Maybe you can spin. What department are you in? You're in the business school?
I'm in the management department, but so my undergrad was in chemical engineering. Then I did management science for my master's, and then I did strategy innovation. So more on the side of, economics, sociology. So I covered all of these kind of things. And listening to you, it was super fascinating, and it brings back a lot of memories in various different ways. So I deeply appreciate everything that you said. I don't know. So I actually would love to keep this all together, because this remaining section for the last 20 minutes has been fascinating. If that's okay.
It's fine with me. I am here just to get the word out to as broad an audience as I can. That's the only thing. So LinkedIn, I have found has been fabulous, but I still do a lot of talks. I've probably given more talks per year since I've retired than I gave while I was still working.
if you ever want to come down to Florida State, I could put a good word out for you. So Tallahassee's a beautiful spot. It's nice and warm in the winter. A little too warm in the summer.
Yeah.
It's
You know,
beautiful.
the idea. So my daughter now lives in Durham, North Carolina.
Gotcha.
And she got her PhD there and said, look, Dad, this is a nice state. It's slightly too warm in the summer, but it's nowhere near what you're going to be dealing with. But she doesn't have the New Jersey cold, and she just settled in and really, really liked it.
It is amazing. Yeah, no, it's especially I grew up in, if you know anything about geography, if you know where Thunder Bay is in Canada.
Yep. Yeah, I've been, my wife and I drove through Thunder Bay right after college.
You would have drove through my hometown if you went across that way, which is 4 hours from Thunder Bay, a little bit more northwest. So, and all of these stories is just, part of the reason why I call it the Reciprocity Project. And it was, how do I give back knowing all of my experiences? And I grew up, not knowing any of these things. This is all such a strange world to me. The whole academic world is a strange world. Growing up in Northern Ontario. So I wanted to figure out, how do I give back? How do I make sure that other people will find the joy of learning as well?
Well, I love this message of, anytime you want to do better, you have to make better decisions. And I came up with my 4 classes of policies. And once I came up with that, I says, okay, so actually solving the problem isn't that hard. I just pick whatever class of policy. Sorry, nothing's optimal. Forget optimal policies. And then I started realizing the more fundamental questions were interesting, like what are the decisions? And so I started moving, in that direction rather than the heavy math direction, because I'm like, the math guys really get it wrong. They really don't know actually how to solve a problem.
You said it. You're much older than I am, so I didn't say it.
Yeah, it was amazing to, I mean, of course, I have a long publishing career, and I had all these grad students who like to publish fancy theorems. So I went pounding through all these heavy math books looking for solution techniques. When I had my truckload problem, I honestly went thrashing from one community to the next, trying to apply their techniques, only to find that it's not that they didn't work. They didn't come close to working. I mean, they were laughably off base until I finally stumbled into something that was more ad hoc. Then I learned how to formalize it, and then many other problems later. And I'm like, oh my God, I think I finally figured this out. The hard thing about the academics is they can't, in my field, they can't survive without publishing.
That's exactly it.
And you can't publish unless you're in one of these little pocket communities making these incremental contributions to whatever the pocket community is.
I think that's how we got linked up on LinkedIn, because I talk a lot about that in terms of what does that actually mean? How do you deal with that, right? Like that's all that kind of stuff is.
In the physical science world, people really are trying to invent something new. And then they want to get a patent and actually go to market. But in the analytics world, it's who does the fanciest analytics. They don't actually worry about who's actually solving a problem. And it's fundamentally broken, and it's really not fixable, because any new person coming in is going to have to align themselves with some community that can read their papers and say, yes, this is a good cut. And then once they get their tenure by following that patent, they're trained, they're done. That's what they're going to do. So it's fundamentally broken.
So I wouldn't say it's broken. I would say, so I take a sociology perspective. I would just say that's just people being people, right? And we have to recognize that science, we have this sort of imaginary view of what science and research actually is, that it's very pure, but in reality it's being created. And there's only 1 or 2 people that I know of that's actually really exploring this. Jack Gonacallo sort of talks about this sort of creativity that happens and the challenges of being a creative. He's really making some interesting insights in that. But if you look at there's a couple of people, one at Northwestern, a group at, I can't remember where, but they use like paper citations, all that kind of stuff. They see all these very normal sociological patterns that emerge, exactly what you're talking about. And it's just, people being people.
The simple fact is, if you're trying to cure cancer, even if it's just in a mouse, you still have to cure cancer in the mouse. It's still something physical. It's still something real. If you want to come up with a new material, you're going to actually be able to test that material in the lab. If I want to optimize a trucking company, you can't optimize the trucking company in a lab. Okay? And so what people do is they do these toy problems and they prove their theorems and they make up a problem to show that their algorithm works. It's never real. And so the analytics community, this is not true for machine learning. The statistics machine learning people, they have real data sets. They test their model on real data. But once you get to sequential decisions, it's this subclass of sequential decisions. And most decision problems are sequential. It's just broken. It's not people being people. It is just broken because the problem is too complicated.
If you're excited about that, I'm always looking for various different, and I deeply appreciate the fact that you've supported the Reciprocity Project so far with the platform. What I was thinking about, if you ever come up with an idea of what I can build into the platform, or if you have something that would be, helpful, I'm always here, right? I'm trying to sort of change some of these things and put some boundary conditions, I guess, on some of it, so it becomes a little bit more easier.
Well, what I would suggest is watch my LinkedIn posts. So if you see me posting on something that you find interesting, that you think looks appropriate for your audience, so I don't think I could propose that, but if you see something, you're going to see me moving more downstream, upstream, closer to the basic problem, speaking English. The one thing that I do is all of my English is driven by analytics.
Exciting.
So even if I'm just doing English, it's still in the back of my mind is I know the mathematical model. I know that I'm filling in things that I can model, because at the end of the day, I want to put it on the computer.
Yeah,
now, if we don't put it on the computer, I want to use the exercise of putting on the computer to help guide thinking. So that pretty much describes me.
Perfect.
I got a dog who says my time is up.
Yeah, exactly. I don't want to keep any more of your time. I just appreciate everything at this moment.
Okay, well, good luck with this project. Appreciate you taking this to a larger community.
Yeah, it is. It's exciting. All right, take care. Thank you.